Okay, our speaker today is Douglas Morgan, the Chief of Locks and Dams for the Illinois Waterway, U.S. Army Corps of Engineers, Rock Island District. Doug has been with the Corps for over 25 years, working his way up. He spent 8 years on the maintenance repair units in Peoria as a lock and dam repairer, work leader, diver, and collateral duties as a crane and boat operator, sorry. Then 3 years as a lock and dam equipment mechanic at LAGRANGE in Versailles, Illinois. Then he spent 7 years as assistant lockmaster at both Starved Rock and Peoria Lock and Dam in Creve Coeur. Then he moved up and spent 6 years as lockmaster at both Starved Rock and Peoria Lock and Dam. And currently, he has served just under 2 years as chief of locks and dams for the Illinois Waterway in Rock Island District. I drive over the Shade Loman Bridge on 474 every day to my job in Pekin, and every day I look at that lock and dam and I wonder what they're doing, why it's there, and so I contacted them and asked Doug to come and talk to us and tell us all about it. So welcome, Doug.
Yeah, good afternoon, Diana. Thank you, Dawn, for that. Is this working?
Yeah. Yep. Okay.
Thank you for that introduction. I appreciate it. Yeah, I've had a pretty diverse career with the. I've had a pretty diverse career with the Corps of Engineers in Rock Island District. My whole career has been spent on the Illinois Waterway, and I'm not a podium guy, so I'm going to kind of meander around. Plus, I don't have a script. I kind of wing it off the slides anyway. So yeah, I've been with the Corps of Engineers now, like Dawn had said, for over 25 years. It has been a very fulfilling job, career to have with them. A lot of experience, a lot of different things have gone on throughout my career, and I've been, I've been pretty fortunate with the amount of stuff that I've been able to see that happened in that 25 years. And I'm always excited to be able to share the story of the Corps of Engineers, particularly with the Illinois Waterway, and what we do for the American people and keeping commerce rolling. So, so it's just some historical background. The locks and dams were pretty much, they were built, they were constructed through the 1920s and 1930s with your uppermost locks from Starved Rock up on north, which I'll get into that in a minute. Those were actually started by the state of Illinois, and this might be a shocker, they ran out of money. So what they did then is, they appealed to the federal government, the Corps of Engineers, and the Corps of Engineers was able to finish up construction of the locks on the upper reaches of the Illinois River. The locks and dam system was as a result of an act by Congress in the 1920s to be able to provide navigation, a 9-foot navigable channel. So our locks and dams, the dams particularly, are not flood control devices. So that's something that a lot of people get confused. These are strictly for navigation. We're there to maintain that 9-foot pool, so all those towboats that you see going up and down the river are able to make it from their port to their destination, moving our commodities up and down the river. Most of the locks are basically the same design as far as the chambers are concerned. They're 110-foot wide by 600-foot long. The dams, however, they vary in design, and that's something I'll get into here in a little bit. Unlike the Mississippi River, there's a lot of consistency with all the different dams and stuff. We've got some pretty unique ways that we try to hold back water on the Illinois Waterway. So yeah, as I forget who the winner was over here, sir, but yeah, there's 8 locks and dams on the Illinois River, the waterway itself, and then there is an additional lock and dam that's located in Chicago, right next to Navy Pier. So kind of what makes up, the whole Illinois waterway system, as you can see, the Chicago River feeds into it. We've got the Calumet River that goes to the sanitary ship canal. And then just below Lockport Lock is where or Brandon Road Lock is where you kind of get into the actual Illinois waterway itself there at Brandon Road. So this here kind of gives you a profile of what the river looks like if you could slice it right down the middle and look at it from upstream to downstream. As you can see on the right-hand side, there's quite a steep drop-off. So each one of those little stair steps represents one of our locks and dams on the river. And so as you can see upriver, you're going to see quite a bit drop difference between what we call pools. And that's how we've got to be able to get these boats up and down this river. If we, and so the thing is, to use that locks and dam system is critical in order for us to be able to provide that service to the country. So then on the right-hand side, you can see where the locations are. Way up on the upper end of the Illinois River, you can see how tightly grouped they are. And as well as you can see there on the right-hand side, how necessary it was because of the steep drop-off in the river. So, and then as you go downstream, you can see below Starved Rock, they start to spread out, between Peoria and LaGrange. And it flattens out, and there's a reason why their dam is the way that it is. And we'll get to that. Some of you guys, I'm sure, are familiar with the WICKETS, or maybe, but you're going to be here soon. So the Illinois River, at each lock, basically the staffing at each lock is set up. You have 10 operators at each site. Those are your actual lock operators. Just 10 guys keep that thing operating round the clock, 365 days a year, 7 days a week. Those guys they're where the rubber hits the road. Then you have your support people at the lock itself. You'll have like a maintenance mechanic. You'll have the assistant lock master, the lock master has site supervision over the whole site. And then we'll have a term employee, which is somebody that we'll bring on as an entry-level position in hopes that we can be able to retain them if they so desire. Also, we have our repair units, which are based out of Peoria, down here by Komatsu, if you guys are familiar with it. That's actually our boat yard. That boat yard then houses our lock support infrastructure, which is all of our repair crews. Our dredge crew comes out of there to keep digging the channel out, to keep that 9-foot channel open as well. So those crews, they have light and heavy lift capabilities. You can see there up in Chicago, they're working there in that lower left picture. They're pouring concrete in that upper picture. They, not only locking boats, but they do all kinds of different tasks. Then over on the right, you're going to see a heavy lift crane. That's our Hercules. That crane is designed to pick up what you see there is a large miter gate. And we'll kind of get into miter gates a little bit, but basically those are the gates for the lock chamber that basically holds back the water when you're taking the water out of the chamber to move somebody from the upper pool to the lower, and they swing in and out, and they meet together in the middle, what we call a miter. That's why they're called miter gates. So that crane has the capability of lifting that large structure and putting it in place, and if they need repair or if they're damaged, then they'll hook onto it and pull it out, and then they can make those necessary repairs. So starting upstream, we'll go all the way up to Lake Michigan. Chicago Harbor Lock, you can see it was built back in the late 1930s, and it's basically the same dimensions with the exception it's a little narrower. It's 80 foot in width. It is a sector gate design, and what that means is, there we go, these are the gates here. See, all 4 corners have a gate. These are pie-shaped gates, and basically what that's designed for is to prevent reverse flow of the Chicago River, because back when they started putting in the system, Chicago, the city of Chicago, way on the lake, when you go up there, you'll see some structures out on the lake. Those are your intakes for the water supply in Chicago. Well, they don't want the Illinois River going out towards the lake. They want to keep it going the other direction. So, so those gates serve the purpose of keeping reverse flows from happening, and then also allowing vessels to be able to come from Lake Michigan into the Chicago River. O'Brien Lock is on the south end of Chicago. Again, it's the same type of miter gates that you see there, and for the same reasons. Typical lift at both of these is just a few feet. So the differences in pool are going to be very, very minimal, but they are critical in protecting Lake Michigan and also still allowing navigation to make its way from Lake Michigan into the Illinois waterway system. Now, we're going to get into where we get some pretty steep drops in the river. This is Lockport Lock, named so for the city of Lockport. Now it's going to have the 600-foot chamber, 110-foot wide. It's got a nearly 40-foot lift on average. When you're standing at the side of that lock chamber, when they have that water all the way down, like you see there in the photo, when you're standing up here on the wall, it's a significant drop. I mean, you're looking way down on these boats sitting in the chamber as they're getting ready to shove out. So it's pretty impressive. So they got these tall miter gates on the lower end. And then what you see on the upper end, this is a vertical lift gate. That vertical lift gate is just like it just goes up and down. And what it does is when they take it down, when they fill the chamber, it ducks down behind this sill, and then the traffic can go right over the top of it into there. And then they can lift it back up so they can then open valves, because there's valves on all the locks that they can use to dump the water that's in the chamber down to the downstream end down here where it will discharge. A lot of people, that's a misconception. A lot of people think that we use pumps. We use, some kind of a mechanical means in order to get the water in and out of the chamber. It's gravity. That's all it is. Just like flushing your toilet. I mean, it's really that simple. Because you have valves and tunnels that run through these walls that basically when you open these valves here, that'll allow that pool to fill this chamber. And then once you close those valves up there and you open these valves down here, it'll allow the water in here then to run out in the lower end. And that's all it is. It's just gravity. Okay, so moving down from Lockport, we're at Brandon Road Lock, another high lift lock. We're approaching 35 feet, I think. Yeah, 34-foot lift on average. Now one thing I wanted to mention about Lockport. There to the left, you see a power plant. That power plant has been there since the turn of the 20th century. As Dawn had mentioned earlier, I used to, on the repair units years ago, I was a diver. I had dove up inside these discharge tunnels for the power plant. It's incredible the condition that the deterioration that they had at that time. So that kind of stuff, I believe, has been repaired. But that is an old facility. And if you look over here, just the old I&M Canal lock is right there. You can see the difference in size between the two. So that power plant is not operated by the Corps of Engineers. That's a private entity, but they do control the pool up above. So moving on to Brandon Road now. Again, high lift lock. Brandon Road is located in Rockdale, but it's just on the outskirts of Joliet. And so they have a long dam out here that's made up of 21 Tainer gates, and then they've got some decommissioned head gates that they use out there, or they do no longer use, but they were used for help control pool. And this year, if you guys might remember from 2020, we had major rehabilitations on the Illinois Waterway at Peoria, LaGrange, and Starved Rock, and also at Marseilles. They're doing the same thing with the upper reaches of the locks this year. So for 2023, they're going to be shutting down Brandon Road. They're going to be shutting down the next two locks I'm covering after this for 4 months to do major dewaters and rehabilitation. So it's a major construction effort that is needed. It's something that we don't get much of an opportunity to do, and we had to be able to coordinate that through our industry partners, the towing boats that you see going up and down the river. So it's something it's a huge undertaking, but it's much needed, just for the simple fact that these don't get the attention that they need, because we operate year round. It's a year round operation. To shut the industry down for 4 months is a huge undertaking. Oh, the other thing I was going to mention too, down at the bottom, it says fish barrier project. That's another thing too. You guys have heard about the invasive carp that is going, you see the videos, the guys, doing their stuff out on the river with catching them with nets, or, hitting them with baseball bats or whatever they were doing. But anyhow, there's a tremendous threat and a fear of those getting into Lake Michigan. And so the Corps is undertaking a project in which at Brandon Road, they're going to put a barrier system down below here, which is an electrified system. They're going to electrify the river, and also an acoustic barrier and a bubbler barrier in which that they will prevent these Asian carp from going up and down the river or going up towards Lake Michigan. There is another barrier in Chicago District at Romeoville that does the same thing, but this is going to be like your first line of defense, and then it's going to be the second one. So there's a lot of work that's involved in that. All right, so down the Dresden Island Lock. This is a lock that's located outside, just upstream of Morris, Illinois. And again, pretty much same dimensions, 22-foot lift, and 9 Tainer gates. Down here, you can see that's a Tainer gate before installation, a new construction. This is what a Tainer gate looks like, and they fit in right over here. And this is the upstream side of the Tainer gate. This would be the downstream side. So this is the side that'd be holding back water. So yeah, they'll have 9 of those Tainer gates, and again, some decommissioned head gates and stuff. But that's how you control pool. If you get a heavy rain up north, or you get some ice melt or snow melt, you'll open up those gates as the pool rises and let that water go. So again, part of another major rehab, which the rehab, for all these sites is going to include, replacing gate machinery, replacing the upper miter gates, doing a lot of concrete work, vertical concrete work on the lock walls and such. So yeah, a lot of work going on. Marseilles Lock. Marseilles Lock is located, Marseilles, Illinois. It's unique in the sense that the lock is located 2.5 miles downstream of the actual dam. So there's actually an island here. If you go up the canal that way towards where the canal or the dam is, the dam actually, which is located here, is actually the stream actually is over on the other side of this island here, and that's where it's controlling the pool is above that stream. So, and it's controlling the pool here in the canal. So it's got a 24-foot vertical lift. They got 8 submersible gates, and the reason why that's different than the one I showed you before is the submersible gates, they can actually submerge them as opposed to just letting water pass under them. The advantage of that is to allow ice and debris to go over the gate to get, to keep the dam clean, and they're easier to maintain because of the fact that you can operate those in ice conditions without having to do what's called steaming the dam, which is using a boiler like at Dresden in the previous lock and Star of Rock, where you physically have to go out there with steam and cut ice off of the gates to keep them operational. They're going to have electrical rehab this year. They're going to replace a lot of electrical components. They're going to do a crossover. They're going to do a crossover from the main lock house to the old lock house where the electrical is all currently at, and they're going to remove it over here, and they're going to do a bunch of electrical work that desperately needs updated. Star Rock. Star Rock is a lot like Dresden Island in design with the Tainer gates. A lot of you guys may have seen it. If you go up to Star of Rock and you like to get up on the bluff, this is the view from the bluff on that lower picture. The other one is a view from obviously an airplane. So if you've flown over Star of Rock, that's what it might look like. So Star of Rock, I worked there for 6 years. Beautiful place to work, especially in the fall. Very busy place to work. It is the home of the Illinois Waterway Visitor Center. So if you guys are wanting to plan a trip and go see the state park and you want to go across and to the visitor center, it's located right there at the lock. They got some great exhibits there. So if you want to learn more, and you can go there and you can stand up on the balcony and you can watch tows lock through. All right, moving down here to where we're at, Peoria Lock and Dam. So I spent a lot of time working here as well. It's unique, obviously in design. You can just see it from the photographs because this guy here is going right over the dam. What's he doing out here and not in here? Well, you guys probably heard, quite a bit, or some of you may have heard, you hear the wickets are up, the wickets are down, and we'll get into that in a minute. But so it's basically just an average of about 6-7 foot lift. If you remember from the earlier slide, the river's starting to flatten out now. So now we have to use these wickets so that way we can be using what's called the navigable pass, and that's what this is. When we get a lot of water, which we actually got a shot of water this week, the wickets went down earlier this week, and now we're running traffic over that pass, just as you see illustrated in that photograph. It's starting to fall out. They may be putting that dam up in the next day or two, and when they do, it'll look like this down here. And they'll use this apparatus here, which is a maneuver boat and a small tow vessel with an excavator that raises and lowers those wickets. And I'll give you a more description of that here in a few minutes. LaGrange, basically, it's down by Versailles, Illinois, and it's same concept, same design as Peoria. It's it looks the same. They just went through a major rehab this year as well. Their operating system, the drive system for their gates and valves have all been changed. All the concrete's been replaced. Their hydraulic system has been replaced. So yeah, a lot of work is going on there. Peoria has 109 of those wickets. LaGrange has, Peoria has 108. LaGrange has 109. And the wickets at Peoria are a little bit taller. They're 16 foot by 14 foot wide. LaGrange's are 14 foot tall by 4 foot wide. And as it says in there, LaGrange and Peoria are two of 3 wicket dams that exist in the United States. The other one is the Olmsted Lock, which is a completely different animal. It's a new construction, and it's like comparing apples and oranges between the two. Wickets. Okay, so getting the wickets. I figured I'll touch a little bit more on this because most of you guys have probably seen this. As Dawn had said, driving over the bridge, you look down there and you're like, what in the world? Well, here's your crash course. So LaGrange wickets, again, 109 foot tall, or 109 wickets, 109 foot tall, 14 foot tall. That kind of blows that whole flatten out river theory right out the window, doesn't it? So yeah, 109 wickets, they're 14 foot tall. Peoria's got 108 wickets, which are 16 foot tall. This is a historical photo during the construction of, those are LaGrange wickets, I can tell just by looking at them. that's a historical photo of the construction when they were building it in the dry. So this is at the upstream side of the wicket here. So that's the downstream side on the other side. So this is the face of the wicket facing upstream. You go to the next page, you're going to see the downstream side. You can see it's pretty complex. This is a lot of fun to dive on. So there's a lot of stuff going on in here when you're down there and you can't see. It's underwater and you are blind. Question you get asked all the time is, what do you see down there? Nothing. It's pitch black. So, but you know what you're looking for or feeling for. Let's put it that way. So you go down in there, you got the herder here, which holds the prop, which, you know, stands the wicket up, and you got the horse, and down in here you got these little horse blocks that are bolted into the river bottom, and you go in there and you start tearing that stuff apart if you need to replace a wicket, or you start putting it back together. So there's kind of more of a wider version of it. So here's a bunch more of these wickets lined up, and down here you got what's called baffle blocks. That's kind of, you know, help with the turbulence and, you know, reduce scouring and stuff like that below the dam. So yeah, as you can see, that's all of them in a row. Not all of them, but a significant portion of them all in a row there. These, again, this is LaGrange. And another view of LaGrange is, you know, just some of the old apparatuses here that they were using to make the construction back in the this is June of '38 when this picture was taken. And then over here was the weir wall. They used to have these butterfly valves in there where they used to control the pool. Well, that has changed. And what they went to after that was a Tanner gate, which I'll get into. So there it is, water, well, with water on it, obviously. So there's that same weir wall with the butterfly valves. There's all the wickets standing up. And that's pretty similar. Again, this is LaGrange, but that's pretty similar to what you would see at Peoria. So here again, you see the wicket standing up. You got the upstream side, you got the downstream side. And this here is an old steam-driven maneuver boat that they use. And this is the actual machine or boat that they would use to raise each one of these wickets one by one. So, and you have to raise each one by one or drop them one by one. So it's pretty labor intensive, and even more so back in the day. When I first came in the Corps, they still use this. I mean, I came in the Corps of Engineers in 1987, and they were still using this, even as, you know, this was from 1938. They were still using it then. This is what they went to now, is that new maneuver boat. This excavator with a special hook is used to hook onto those wickets and raise them. So a lot safer. It's a lot, you know, you don't, and you can do it much more quickly, more efficiently. And of course, like I said, it's safe. This is that Tanner gate I was talking about. That's what replaced those butterfly valves on the opposite side of the river. So they actually, when they did this, this is right next to the lock chamber. So the lock chamber for LaGrange is located over here. So this Tanner gate is what they use to control pool, to move ice out of the way. And, you know, and so it's critical for us because ice is a huge issue during the winter months, and particularly at LaGrange, it's really, really bad. You can get a lot of ice stacked up on there, and I'll have some examples of that here in a minute. But for the most part, that is your pool control, as opposed to those old butterfly valves. Those butterfly valves have been decommissioned and are now filled basically with concrete. So they're out of service now. So that's the maneuver boat in operation right here at Peoria. You can see the bridge you guys cross all the time. There it is. So they're raising these wickets up in this photograph, and what they're doing is they're making this turn. And they're raising the first 20 wickets, and that's the critical part, because it's a lot of jockeying that boat around. Once you get those first 20 wickets up, this boat will bring its stern down and it'll lay flat across that dam, or with the wickets that are standing. And then the small tow vessel will get on the hip over on the opposite side, and they'll have a return winch wire that's catching a wire on the wall that they actually control the movement of that maneuver boat with. And then they'll go on across the river with that excavator and just keep popping up each one wicket at a time. Sometimes it goes good, sometimes it goes bad. Sometimes there may not be a wicket there. So they do, I mean, it is something that can happen. Maintenance is key. Our guys do a good job of keeping it maintained, but they are something that they take a lot of abuse.
How often do you raise and lower those?
Depends on pool levels. So some years you could go some years you could go maybe once or twice. You can go out there to raise and drop. You know, then other years, I know when I was a lock master there, I think our record at that time, I was out there 19 times. So you figure that was, you know, almost once or twice a month. But yeah, so you get these big fluctuations in the river, and things are changing differently now than it did back in the day. The river doesn't respond like it did just 10, 15 years ago. It's continually, it's its own living, breathing animal. And it just, you know, we could go back in the record books and look at how they did things and the conditions that they were under, and it could be completely different than what we're experiencing now. It's just the river changes. So right there is the excavator. So there they're reaching in, you know, this is like, you know, was reaching in to raise a wicket. Caterpillar, yay. So, so yeah, and then this is them actually, and it's hard to tell, but they're dropping the dam. And what that means is, and you'll see in some other slides here how that works, but they kind of pull that wicket upstream a little bit to allow that prop to disengage, and they can let it go, and it'll just slam right down to the river bottom on its own, usually. So, well, unless there's a tree or a buoy or something under there. So, yeah, this is the boat that we use to propel that maneuver boat across the river. And they've got one at each side at LaGrange and Peoria. There's just some of the specifications on it. So yeah, it's critical to the operation. If we don't have that boat and we don't have propulsion, then we've got nothing. So now here's the model of the wicket. I guess I should have brought it, but basically this is kind of giving you a better idea. That excavator is looking for this bale. And that's what they're picking up on. And I'm going to show you in some very highly technical pictures coming up next how that works. So if it gets too technical for you, let me know. There's my finger. So anyhow, so this is the wicket laying on the bottom. That's how the ones at Peoria and LaGrange are positioned right now. This is the upstream side. The water's flowing going that way. So what'll happen is the excavator will reach down, they'll grab that little bale, and it'll pull that wicket up. And this is the horse that it pivots on. And there's a prop that's sliding along what's called the herder, which is this thing right here. So that prop slides along the herder, and he picks up and he pivots on that horse. And once he gets up, that prop actually hits a catch point. And once it does, right in there, it'll hit that catch point, and that excavator hook will actually jerk when it hits that. You'll know you've got it. And so once you've got it, you just let go, like my highly technical finger shows you. And once you let go, the current, as it's coming through there, will push that end up, and it'll just stand up on its own. It'll just like magic, just flop up. Yeah, it's pretty neat how it works when it works. So sometimes, sometimes this herder gets filled with sand, debris, rocks, cable, buoys, whatever. And it may take a lot of work. You don't know what's in there because it's underwater. So you'll sit there and you keep trying to stand that wicket up, and it won't catch, the prop won't catch that part. And when it doesn't catch, you got to keep working it and working it. And sometimes you got to skip it and come back to it, because once you get the rest of the dam up, you get enough wash going through that hole, it might clean whatever in there is out. Or you can just keep slamming that wicket down and allowing that hydraulic action to kind of whoosh it out, you know. So there's different techniques you can use, and typically we're able to get all the wickets stood up. There's on a few occasions you can't, and you kind of let it be, and then you'll go back out and try it again in a day or two. And more oftentimes than not, you're able to get it stood up after letting it wash out for a little while. So also we get into low water environments, and what that means is we go through a drought situation. We don't have a whole lot of rain, and those wickets, there's usually about a couple-inch gap between each one. We'll have the Tanner gate all the way closed because we're trying to hold back all the water that we can. And what we'll do then is, because we're still trying to hold back water, but we've got the gate closed and we're still struggling, we'll put needles in. It's a very manual, labor-intensive thing, but basically it's a 4x4 that's 20 foot tall. And you literally, by hand, pick one up, set it in the river, and then slam it into those cracks between the wickets. And you can see how they're lined up there. So the excavator will help a little bit. You'll get into that crack, and the excavator will reach out on top of that 4x4 and shove it to the bottom. And so that, once we have needled the dam, we've got the Tanner gate set at 0. We have done everything we can at that point to hold back water in a drought situation. That's all we can do. So on the lower end, that's them pulling the needles. Basically, here they just take a chain. It's like a lasso. They'll throw it around that thing, and the other end's hooked to the excavator. The excavator will yank it out between the wickets, and then they'll land it on the deck of what we call the needle flat, and then that's, you know, then we'll put it aside until we need it again. So dropping the wickets, again, there's just, some pictures kind of illustrating that. So that they pull up on that. What he's doing is he's pulling up on that wicket. What that does is it takes that prop out of that catch point and slides over into a little trough there. And then once he lets go, it'll lay back down. So that prop then will just slide right down the right side of that herder trough and just free fall to the bottom. It doesn't, you don't lower it down, you don't do anything. It'll just free fall to the bottom. Operational challenges. So yeah, I mean, this is some of the stuff that they deal with. Tons of ice. LaGrange gets it worse than we do at Peoria. Fortunately for Peoria, we have a ARCO fleeting service above us. They help us out a lot with ice mitigation. So what I mean by that is they help push ice through that tainer gate that I showed you in that previous photo. LaGrange, however, they have a tainer gate and they can move ice through there. There's no fleeting service above them to really help them. It's 6 miles upriver, and they're very hesitant to come down in these ice conditions to do this. So it requires constant work to kind of keep it flowing. But like the worst of these pictures is at LaGrange. You can see above the wickets, I mean, that's as high as that ice is stacked. And also after huge rainstorms, the debris that comes down on the dam, huge trees and everything like that. I mean, that's just some of the stuff you got to go out there and keep cleaned off the wickets. It gets pretty messy out there. But yeah, between ice and debris and flooding and stuff like that, it's constantly poses a challenge for our guys out there. All right, these wickets are made out of oak timbers. You're thinking, wow, we're in the 21st century. We're putting wood, oak timbers, and iron in the river that hold back water. Yeah, that's what we're doing. So,
Very progressive.
and it's a commodity that's not as available as it was 50 years ago, 80 years ago. It's a commodity that's getting harder to come by, and it's getting quite expensive. And and you can see it rots. It gets in bad shape, and it's not doing its job effectively anymore. So these guys continue to keep cranking them out. I mean, as best they can. This is right here in Peoria, right there in our boat yard there by Komatsu. These guys will rebuild wickets with new oak timbers. They'll take the old wickets and they'll take the hardware off and put them on the new oak timber. So they recycle that part of it. So that's good. So yeah, I mean, our guys there in the yard are fantastic. These guys, they've got so many different skills and abilities. It's just mind-boggling the things that they can do, from crane operating to carpentry work to diving to iron work to welding to machining. I mean, we've got a huge capability there in our project office that is just, I mean, even it still amazes me after 25 years of being, working out of this project. So there's Diver. That's not me. I quit that stuff back in 2004. But yeah, that's these guys are lowering a wicket down into the river for this diver to hook it up. There's a base that it hooks into with it's called a horse block with some bearings and some bolts and stuff like that you do to get that secured to the river bottom so they can put it back in operation. So the diver goes down off the maneuver boat out into the water, and he stands by as they lower a wicket down into the river. And on the upstream side, what they'll have is a bulkhead. Yeah, this is a different type of bulkhead. Let me go back. But they'll have a bulkhead holding water back from that hole that wicket is no longer in. It kind of takes the place of the wicket. And so that diver will go in there, hook it up. They'll stand the wicket up. They'll pull that bulkhead, and then they'll move on to the next one that needs addressed. So yeah, that's kind of gives you some background on a typical dive team. How many people are involved. And divers are dual. Yeah, divers are dual rated people. I mean, when I dove, I was a diver and a work leader, and I was a diver and a crane operator, during that time frame. And so, so the thing is these guys here have collateral duties and other jobs with the Corps besides just diving.
You get someone to dive more than once.
What's that?
How do you get someone to dive more than one time?
That's a good question. I think we're kind of crazy.
Yeah.
Yeah, it is. It's lights out when you get in there. It's let me put it to you this way. I'm a simple guy. If I can do it, most people can. That's the way I put it. If you're not claustrophobic, and I equate it to this. Let me put it to you this way. You're in bed at night. You get that urge. I gotta go to the bathroom. Lights are out. You know how to get there.
Sure.
Okay. you fumble your way out of bed to the bathroom, take care of your business, and get back to bed, right?
Sure.
The same difference here.
But I'll lay there until it's an emergency. I don't volunteer it.
How long does a wicket usually last before it needs to be replaced, before the timbers rot?
Yeah, the question that he asked was basically, how do you get somebody that once they start diving to do it again? In other words, he's inferring that, you get in there and you're thinking, oh, this is nuts, I'm never doing this again. It's basically, the point I was trying to get with the bathroom analogy is that you get familiar with the surroundings. You know what to expect when you go down there. And if you go into unfamiliar surroundings, because we are the Corps of Engineers, we got drawings of everything. So a diver can look at a drawing and say, I'm going to go in this lock chamber, and I see there's a sill here, there's a bubbler pipe there, there's a grating here. They'll know what to expect when they go down there. So the thing is it's by feel. Everything's by feel, but it's just, I always like to use that bathroom analogy because, I relate to it. I don't know if you guys do, but, so the thing is that's basically, and when you go down there, I'll be honest with you, it's not that bad. Except in the winter, it really stinks. But, yes, sir.
Tethered?
Yeah, you are tethered. So this guy's got an umbilical. You're weighted to the bottom. There's no flippers. You're not swimming down there. You're crawling. So everything you do is crawling. Diving for the Corps of Engineers, at least in our district, you're weighted to the bottom, or you're hanging from a rope or a line or something like that. You don't do any swimming, so there's none of that. You had a question, sir?
Yeah, years ago, Juniors, we built the Spirit of Peoria boat outside of St. Louis and came out, brought it up a long time ago. And we wait hours at the locks because the commercial ships went through before we did.
Okay.
And so I guess my question is, what happens if there aren't any locks? Is it primarily for flooding that we need them?
No, the locks are primarily built for maintaining a 9-foot channel for all the commercial traffic, or even like the vessel that you were on. We've got to maintain at least a 9-foot channel, and in doing so, those locks are holding pools above them.
Okay,
So
it's height.
Right, it's more of height. It's not flood control. So the thing is if we didn't have those locks, we wouldn't have navigation on this river. You'd still have the river. It'd be just shallow, or it might even kind of become somewhat of a creek at times during some events, but yeah, it's.
Well, I was thinking of the Indian canoes that would go up and down, and they may.
Yeah. There you're drafting a few inches. Oh, did I do that? What's that on the screen?
What is it? Oh.
I got some colorful stuff over here. Okay. So anyhow, but yeah. You were asking about how long a wicket lasts.
Yeah.
Okay, a wicket typically will last 10 to 15 years, an oak wicket. So they'll have to be replaced about every 10 to 15 years. And we've always kept records on when they're replaced. There's a logbook, and stuff. So we kind of know when to expect that they're going to start to go bad. However, we have a solution. So
I was waiting for it.
Click again. There we go. We're starting to get to it, and this is a little bit of a sneak peek. Is this one over here? But first, some of the tools that they use are these dewatering bulkheads. So you'll set this dewatering bulkhead. It sets on the upstream side and the downstream side of the dam, and it rides right between the cracks between the wickets that you see here. So it'll set down over there. You'll put shutters on the upstream side and the downstream side. Divers will then go in and seal around the bottom, and they'll run pumps and they'll pump it out. Then you can get to the bottom and you get exposed. And this guy's standing on the river bottom, so that's inside the dewatering bulkhead. You can see these are the mounting areas for the wickets in the river bottom. There they're replacing a base plate, and there's a horse block that sits up on there. I don't think I got a photo of that. There's a horse block that sits on there, and it's bolted with a T-bolt through that base plate, turned 45 degrees, and then it locks in, and then you bolt that horse block down. Then the wickets, the bottom of these horses, then fasten into that, and that's why it anchors into the bottom. This is composite material, and we'll get into that here in a minute. So there we go. Composite wickets. Okay, you saw the rotten wooden wickets. So now they wanted to solve that problem. Now the Corps of Engineers, the Engineering Research and Development Center down in Vicksburg, Mississippi. I'm glad I got that acronym right. And the University of West Virginia Those folks collaborated together to put in 3 prototype composite wickets. Now, I could get into the whole scientific makeup of these composite wickets, but I don't know what it is. I call them plastic wickets, fiberglass, plastic, whatever. But they have been tested to the nth degree. They behave just like their wood counterparts. The engineers did a great job of ensuring that they balance the same way, they weigh the same, that they drop the same, that they float the same. Everything, they did a fantastic job with these prototypes that we are now ordering them to basically replace all the wickets at both dams. And these here will have basically a 50-year service life as opposed to 10 to 15 years. So that's something that's going to be changing over the course of the next few years. We'll start seeing more of these getting installed. And the Corp of Engineers, this is a funny story. The Corp of Engineers actually has a historical office up in Rock Island, the district we work out of. They were concerned that these wickets were yellow and not brown. They were really worried because it was, you know, because history is like, okay, we got to make this, you know, like the lock houses are historical landmarks, the locks are historical landmarks. We don't want to do a whole lot to alter those structures and those facilities because then we take away from the historical significance of them. But doggone it, we can't have yellow wickets. So we won that battle. So yeah, it's one of those things where they kind of brought that up, but yeah, you know, and the thing is, I don't think the fish are going to mind. So anyhow, I guess at that, if anybody's got any questions. Yes, sir. Yeah.
How do you maintain the water levels when the locks are open?
Okay, the question is, how do we maintain water levels when the locks are in operation? Yeah, basically, during that presentation, I was pointing out the dams with the Tanner gates, and then also like with the submersible gates, and then with the wickets, it's a little different because they're set at a certain height. At Peoria, they're set at 440 which is an elevation above sea level, 440 feet. And so that Tanner gate that they installed, that's what they use to maintain the pool. So if the water starts to ride a little high over that 440 level, you get a lot of water over the top of the wicket, you open up that gate some more, and they'll draw that pool back down to the 440 level. If it starts to get under that, you close the gate off a little bit, back that water up, and then maintain the water back to that 440 level. So I'm using Peoria as an example, but all the locks have their different levels that they will want to maintain. And with that, they'll do that using their Tanner gates. In the back, you had another question?
Yeah, when are you scheduled to do the lock repairs?
For this year, they're going to be starting 1 June, and they're going to go through the end of October. So, and that includes Brandon Road, Dresden Island, and Marseilles. The ones down here are going to be fully operational from Starbrook through Peoria and LaGrange. Those will be fully operational.
So you won't be able to get to the lake this summer then?
Correct. Yeah. So, and I do, you know, like I'll have like these, they call it the loopers, the people that, you know, basically, I mean, they're in touch with me. I get on a couple of podcasts with them and stuff and kind of update them on some of the stuff that is going on and some of the dates and what to expect. And they ask for our advice on how they, you know, sort of stage themselves and stuff. So, but yeah, as far as like being able to have access to Lake Michigan from 1 June through the end of October, that won't be happening, at least on the Illinois Waterway. If you want to take the whole route all the way around, yeah. I'm sorry. I'll be with you.